So this is the second of the two videos for the week. And this one is going to be on energy and then a little bit on the end maybe system. So what we want to talk about here is there's really technically two forms of energy, kinetic and potential. And so kinetic energy is always defined as the energy of motion, movement, things like that. And potential energy is the energy of position, where it's located and or stored energy. And so what we want to do is look at a couple of examples of these and then talk a little bit about some of the concepts you need. Okay, so here's kinetic energy in this picture. And if you're looking for the kinetic energy, I mean, you can see water on here. And reality is, what I like about this slide is technically both energy sources are here. So kinetic energy is this water coming out of the dam. The dam is open and they're releasing water. So you see that on the bottom here. And then up on top, what you see is a bunch of stored water. So this would actually be potential energy back here behind the dam. So this actually has the definition of both. Here's some potential energy. And it's gasoline. And I don't know if you look at the price on where this thing came out, maybe the clothes and the cars. But this guy, actually gasoline is a potential energy. It's stored. And what we do is we take that energy, put it into our car, and then we change that energy into kinetic energy to use that to propel our car down the street. Okay, so potential energy. And if this guy had a gut, that would be potential energy. Energy of storage. Okay, so here's what I need you to know. Energy can be transferred or transformed, kind of like we talked with matter before, but it cannot be created or destroyed. So what we're saying is energy can be traded from kinetic to potential and back again, and that's what we're seeing here. Potential energy in gasoline, and on the right, you can see this car is driving down the street. That is now kinetic energy. So we are not destroying it or even creating it. All we're doing is transferring it from one kind to another. Now this car should be taken off the market. Hopefully it's still not on the road with all that pollution coming off the back end. And it's an ugly car, so two reasons. All right, the second law of okay, so you want to know these two laws. So again, this is the first law of thermodynamics, and this is the second. And the second law of thermodynamics says every energy transfer or transformation increases the entropy of the universe. And I want you to know the word entropy, and that means disorder. So every time you go from one type of energy to another, the energy, basically, molecules get more disorganized. You end up with more disorder. And what that does is it changes that energy into maybe a less usable type of energy. So as we shift from kinetic to potential, or potential to kinetic, you lose some of that energy, usable energy, and that's usually given off as heat. And that's why we have radiator systems on our cars to keep it cool, because your engine heats up. Some of that energy in the gasoline is pushing your car down the street. Unfortunately, much of that is given off in the unusable form of heat. And so that happens quite a bit with all of the switching. Matter of fact, I think gasoline at its best in a car is about 40% effective. All right, that brings us to Vogel principle, page 118, number 4. Matter and energy are indestructible, can be readily transferred to less desirable, unusable, and even harmful forms. So when we break things down, you know, it can be usable, and we definitely do that. And again, like moving cars and driving equipment, that's definitely usable. But it can be unusable, you know, and even heat can be usable. We heat our cars, you know, you have a heater in your car, and some of that heat can be brought into the cab to warm you. And then it can be even harmful, whereas if you don't have a radiator system, it will just melt your engine parts. So know that. And then let's look at the principles of sustainability and fossil fuels. We're going to talk about these a lot more later, but I want to bring them up now. They're in this chapter, so we'll talk about this. But solar energy, we mentioned this with the trophic levels. You know, 99% of all energy used by humans will come from the sun, but we're only using 1% of that. So we're using 99% of the 1%. So it's amazing how much energy actually is out there. But humans, you know, and this, not directly, and we're not talking solar panels, we're talking history of how the fossil fuels were formed and all of that. So bottom line, the 1% is then the burning of fossil makes it the remaining of the energy used. And unfortunately, right now, 90% of that is coming from non-renewable fossil fuels. So lots and lots of numbers here. But I want you to know, actually, solar energy is really kind of the powering force here. Okay, and so that leads us to the next principle, which is the ultimate source of all energy is the sun. And so without that sun, and I keep telling you, you're all going to die. That sun will eventually burn out, and that is still billions of years from now, and we might destroy ourselves way before that time comes. I don't plan on still being teaching by then, but you never know. And maybe you'll still be trying to pass the class. We will see. And that is the recording. And so we will stop the share and we will stop the recording.